Well, hello. Today we are going to look at a very classic trigonometry lab. How tall is the flagpole? Let's look. As you can see here, we've got our scout out looking, and he can see a flagpole. And we're going to use trigonometry to measure its height. Now, there's no way I can climb to the top of that flagpole and measure, so I'm going to have to indirectly measure that. First, let's establish a right triangle using line of sight. I recognize that the horizontal distance from me to the flagpole is parallel to the ground, and I'm going to assume the flagpole was installed correctly and I have a right angle here. Further, when I look straight to the very top of the flagpole, I create a right triangle, and that right triangle is what we'll use for our trigonometry. Okay, now that I have a right triangle clearly established, let's gather some measurements. It is absolutely measurable for me to measure from where I'm at to the flagpole. I can mark it on the ground and walk over to it. I can use a tape measure, many different methods, but it's absolutely measurable. Another measurement is going to be this angle from me looking up to the flagpole. Now that's a little trickier to get, but I'll show you how to do that in the next step using what we call a clinometer. Alright, a little side note, a quick and easy measuring device to create on your own is called a clinometer to measure angles up. First, start with an index card or some sort of hard stock paper, and on that we are going to create a protractor, make a nice smooth curve and divide it up equally into pieces. The more equal measurements you can get, the better your will be. Notice that instead of a normal protractor with 90 being down, this time 0 is straight down, 90 is along the edges. So as I do that, that's going to create this shape, and if I'll attach a straw to it and hang some sort of device like a paper clip or a washer, this will create. So I look through the straw, and as this holds straight down, it will give me the measurement. Back to my problem at the flagpole. Let's focus just on the triangle, and now let's use some of our measurements. Let's say, for example, we were able to measure the horizontal distance to be 21 feet and the angle to the top of the pole to be 50 degrees. Well, our unknown height here on the triangle is x. Now I can apply SohCahToa. With x being the opposite and 21 being the adjacent, I'll definitely use the tangent ratio to find x. So the tangent of 50 degrees will be x divided by 21. Multiplying both sides by 21 and making sure my calculator is in degrees, I find out that x is approximately 25 feet. Now, is that the height of the flagpole? No, that's not the height of the flagpole. There's still a missing piece. Let's figure that out. Taking my measurements and my new answer back to the original problem, I can see that 25 feet is from the top of the pole to here. But what about this part? Well, that part happens to be the same as your height. So one extra step to find the height of the flagpole. I'm going to measure from the ground to my eyes and then add it to x. So if I happen to be 6 feet tall to my eyes, I'll add 6 feet to the 25 feet that I found using SohCahToa to find that the height of the flagpole is 29 feet. Well, there you have it, the classic how tall is the flagpole problem. But just remember, this really can work on any indirect object, anything that's very tall, not just a flagpole, but any kind of building or tree or any tall object where it's not possible for you to climb to the top and measure straight down. Thanks for watching the classic flagpole problem using trigonometry and indirectly measuring tall objects. Be sure to like and comment below.